3:47 a.m. Something that should have been impossible is happening over Russia. Four objects are racing toward Moscow at about 236 miles per hour, invisible to the most sophisticated air defense networks on Earth. The S-400 radar crew outside Ryazan only sees blips that look like a flock of birds. Except, birds don't fly in perfect formation, and they certainly don't head straight for the country's largest oil refinery. With 32.3 miles to the target and 16.8 miles to the S-400 battery, the lead craft suddenly climbs to roughly 2,625 feet. Ballistics say an interceptor needs 27 seconds to reach that intercept point. The drones will reach the 2-kilometer dead zone in 41 seconds, leaving the battery commander just 14 seconds to decide: real threat or decoy? His calculus is cruel and simple. Each 48 N6DM interceptor costs about $2 million. He orders 2 to fire. They roar out of their tubes and hit roughly Mach 6 in 3 seconds. Then, watch the drones. They dive to about 656 feet and vanish below the radar horizon. These particular weapons use semi-active radar homing. They have no onboard search radar. They need the ground station to continuously paint the target. Without that illumination, they're blind. The interceptors predict where the targets were, pop their warheads, and detonate about 262 feet above the drone's last known position. Fragments scatter through empty air. Close enough to look impressive, not close enough to matter. The refinery's last line of defense are 2 Pantsir-S1 batteries. They have roughly 17 seconds to acquire and engage. The 1RS-21E radar is optimized for larger signatures. Against 1.08 square-foot targets at 5 miles, the return is barely above background clutter. Operators see intermittent contacts flicker. The two A38M twin 30mm guns try to slew, but hydraulics take 3.2 seconds to rotate 180 degrees. Too slow. The lead beaver locks onto its aim point, and the warhead hits. Then 3 more beavers hit 3 more critical points. The strike cascade consumes an enormous amount of fuel. In under 90 seconds, the western section becomes an inferno, temperatures spiking to roughly 2,000 degrees centigrade, about 3,600 degrees Fahrenheit. It burns for days. Moscow's fuel supply is cut by about 40%. The hit is immediate and strategic. What's terrifying here isn't just the physical damage, it's the way low-cost countermeasures and split-second human choices turned a billion-dollar defensive system into an expensive fireworks show. A few cheap reflectors and a clever tactic forced the defenders to spend millions and still fail to stop a catastrophic blow. In modern war, the edge often goes to whoever understands the system's assumptions and can break them faster than the other side can adapt. About 290 miles to the west, another wave was already on its way. 12 drones streaking toward a different refinery. The Russians thought they were ready. 3 Pantsir batteries arranged in a triangle, overlapping fields of fire. Each 1RS-21E capable of tracking up to 20 targets and engaging 4 simultaneously. The playbook was known: detect, classify, engage. Then, at 4:03 a.m., everything changed in an instant. 4 of the 12 climbed to around 1,640 feet and exposed themselves. The classification algorithms flipped. The radar signatures suddenly matched those of KH-101 cruise missiles, aspect ratio, speed, and frequency response, and the system issued a top priority alarm. The trick was straightforward and brutally effective. Those climbing drones deployed corner reflectors, small triangular aluminum panels that retro-reflect radar energy. A tiny reflector can make a drone look like a cruise missile on radar. The defenders reacted as their training demanded. Treat cruise missiles as the top priority. Dozens of interceptors blasted into the sky. Millions of dollars chased aluminum foil. While the defenders' eyes and missiles were drawn upward, 8 more drones swept in at about 165 feet, coming from the opposite direction. Pantsir's phased array radar can electronically steer its beam about 45 degrees left or right, but to look directly behind it, has to physically rotate the whole 3,000-kilogram turret. Nearly 5 seconds of mechanical traverse. That pause was all the attackers needed. Short-range missiles can't arm their proximity fuses fast enough at that point, and the guns must do the work. The 30mm cannons fire thousands of rounds per minute, and their fire control leads targets based on predicted motion. The attackers deliberately introduce random altitude and course changes, turning prediction into probability. Hit probability plunges. A few drones die in the muzzle blast, but several get through and puncture storage areas. The result? More fires, more explosions, more strategic disruption. This is a pattern. When a defense is built on fixed assumptions, target size, flight profile, engagement geometry, the attacker only needs to change one parameter to make the whole chain misfire. When the chain misfires, the impact is not only physical losses, but a loss of confidence in the system that is supposed to guarantee security. 4:18 a.m., a new layer of the fight unfolds. 6 UJ-26 Beavers approaching Venezuela go blind. GPS fades, communications die, navigation screens go white. A Krasuka 4 electronic warfare vehicle just came online and flooded the spectrum from 0.1 to 18 gigahertz with hundreds of watts of directed power. To put that in perspective, GPS satellites arrive at the receiver with around 0.000025 watts. The jammer's relative strength is astronomical. It's like trying to hear a whisper inside a jet engine. The drones switch to dead reckoning using inertial measurement units, but IMUs drift. Over a 380-kilometer flight, accumulated drift can be on the order of 200 meters. Processors heat up to 95 degrees Celsius and begin thermal throttling, cutting clock speeds and reducing pattern-matching performance. Precision collapses into probability. In that crisis, a desperate improvisation saves the mission. Frequency-hopped microbursts. The lead drone transmits 128 bytes on 1,000 rapidly changing channels. A tiny burst slips through a spectral gap the jammer can't cover. The other drones pick up the fragment with matched filtering and correct course. One tank, Tank 7, becomes the unintended waypoint. A warhead strikes where steel meets concrete, a structural weak point, and a fuel lake ignites. Crews abandon vehicles as a wall of fire advances. The psychological effect is immediate. Less than an hour later, the southern theater explodes into a combined operation. 8 UJ-22s attacking Primorsko-Akhtar airfield, a fortress with 4 Tor M2 systems in diamond formation, overlapping coverage, 2 Su-35s on station at 26,000 feet, every radar up. Command modeling predicted near-certain intercepts. But the UJ-22s don't fly straight. They weave in a sinusoidal snake pattern that increases path length and creates process noise in the fire control filters. When 4 Tor systems fire simultaneous salvos, 8 missiles accelerate to intercept. 10 seconds to impact. 9, 8. Then, the drones pull a vertical 6G climb to about 660 feet in 4 seconds, far exceeding the maneuver envelope the 9M38 interceptors can follow. One missile gets a spectacular kill, and everyone looks up. That's exactly the point. Attention and sensors look up. 15 seconds later, 4 UJ-26s that flew low over the sea at about 16 feet crossed the beach. For hours, they had used radar altimeters to hug the waves, a route with effectively zero coastal radar coverage. They hit the Shahed storage hangars. Hangar after hangar is blown apart. Hundreds of stored Shahed 136 drones are vaporized in seconds. The base is effectively eliminated. This phase shows multi-domain coordination, kinetic action, EW, deceptive signatures, low-altitude maritime approach. It's a systemic attack that targets visibility and timing, not just hardware. 4:44 a.m. 2 modified UJ-26 Beavers reach Penza, roughly 391.5 miles inside Russian territory, a strike range that should have been impossible. Range is extended by hard choices. The designers sacrificed explosive payload for fuel, replacing about 11 pounds of explosive with an extra 3.17 gallons of fuel, trading blast for reach. An Su-35 pilot hunting in the area locks onto the drones using a narrow-beam, high-power radar mode that concentrates energy for maximum detectability against tiny signatures. He fires 2 R-77 missiles. These are active seeker weapons with their own onboard radar. One R-77 detonates early, spraying hundreds of tungsten balls. The other scores a kinetic hit and turns one beaver into a pattern of debris. The damaged wingman, though crippled, keeps flying. The final seconds are arithmetic. The flight computer computes trajectory, remaining thrust, and time to impact. The crippled drone impacts at about 163 miles per hour. 15 kilograms of explosive detonate inside a semiconductor fabrication facility. Clean rooms, air filtration systems rated for submicron particles are instantaneously contaminated. Electron beam lithography systems costing tens of millions of dollars and requiring many months to install and calibrate are ruined. Ion implantation gear is destroyed. 6 months' worth of military microprocessors are lost. The local military chip production capability is effectively paralyzed for at least half a year. The strategic consequence is what commands attention. A multi-layered campaign, radar deception, saturation with low-cost reflectors, electronic attack, and sea-skimming approaches, and surgically delivered kinetic hits on high-value industrial targets forces a major reallocation of defensive assets. To protect rear-area infrastructure, high-end systems must be pulled from frontline coverage, creating gaps on the battlefield. That, in turn, frees long-range rocket systems to operate with greater freedom. The math is stark. Ukraine spent a few $100,000 on drone hardware and tactics to inflict tens of millions in damage. But the greater victory is psychological, proving reach, undermining deterrence, and forcing the opponent into costly strategic trade-offs. If drone swarms at this cost can reach deep into territory and destroy critical nodes, then every defender must reassess priorities and spending. How many billions are you willing to spend to eliminate every blind spot? The scenario doesn't end in a simple win or loss. It opens a new cycle of adaptation and counter-adaptation in modern warfare.